angular momentum. In translation, in translation we say that this momentum is simply mass into velocity. When we talk about angular momentum or moment of momentum, say about some axis, because the rotation is going on, this is a vector quantity, and the magnitude is what? It is the product of magnitude of momentum, which is angular momentum or momentum, because we have to relate angular momentum with momentum. So it is a product of momentum and the perpendicular distance of line of action of this momentum from the axis of rotation. And what will be its direction? The direction will be perpendicular to this R and P. Okay. So this L here, angular momentum we represent by L. This is the momentum, proper momentum, and this is the distance vector, which is perpendicular distance from where this momentum is there, and this is the distance from the axis. So the SI unit of angular momentum is kg meter square second per second. Dimensional formula m1 L2 t minus 1. So the geometric interpretation of angular momentum of a particle is equal to twice the product of mass and the aerial velocity. The torque and angular momentum is how they are related. Torque is nothing but the rate of change of momentum, which is angular momentum. Torque is nothing but the rate of change of angular momentum. If there is no external torque which is acting on a system of, then the total angular momentum of the system will remain conserved. This is principle of conservation of angular momentum. Mathematically, if you want to say this torque, if this external torque is 0, then the L1 plus L2 plus Ln, all these momentum combined L will remain constant, because there is no external force, or sorry, no external torque. Whenever we are talking about angular terms, we will talk about torque, not force.